Welcome all for this VLSI design lecture series. In today's lecture video, I'll be discussing about how logic gates are designed using MOSFET. And specifically, in this particular video, let us understand the operation of an inverter or a NOT gate. A metal oxide semiconductor field effect transistor, which is commonly called as MOSFET, is a field effect transistor where the voltage determines the conductivity of the device. A MOSFET is by far the most common transistor in digital circuits, as hundreds of thousands or millions of them may be included in a memory chip or a microprocessor. In general, the MOSFET is a 4-terminal device with a drain terminal, a source terminal, gate terminal, and a substrate terminal, which is also called as body terminal. The body terminal normally will always be connected to the source terminal. Hence, normally for all our theoretical analysis, we consider the MOSFET has 3 terminals. It operates as a 3-terminal device, namely drain terminal, source terminal, gate terminal. But in addition to these 3 terminals, there is one more terminal called as substrate terminal or body terminal. But normally, because this body terminal or substrate terminal is always connected to the source terminal of the MOSFET, in 99% of the circuit, it will be done that way. Hence, we consider, for all our theoretical analysis, we consider that the MOSFET is having 3 terminals, namely drain terminal, source terminal, and gate terminal. There are 2 kinds of MOSFETs: enhancement mode MOSFET and depletion mode MOSFET. So under the enhancement mode MOSFET, again, there are 2 classifications: N-channel MOSFET, which is normally called as NMOS, and P-channel MOSFET, which is normally called as PMOS. Normally, under digital abstraction, for NMOS transistors, when the gate voltage is greater than threshold voltage, NMOS turns on, or when the gate voltage is equal to 1 under digital abstraction, NMOS turns on. When the gate voltage is lesser than the threshold voltage, NMOS turns off. Exact reversal of this NMOS is nothing but PMOS transistor. In NMOS transistor, when the gate voltage is greater than the threshold voltage, NMOS turns on. Or when the gate input is equal to 1 under digital abstraction, we normally call that NMOS transistor turns on. When the gate voltage is lesser than threshold voltage, NMOS turns off. Or when the gate input of the NMOS transistor is equal to logic level 0, NMOS turns off. Symbolically, NMOS transistor is represented somewhat similar to this. We have 3 terminals: gate terminal, source terminal, and the drain terminal. When the gate terminal of this NMOS transistor is supplied with logic level high, there is a connection established between the source terminal of the MOSFET and the drain terminal of the MOSFET. When the gate terminal of the NMOS transistor is supplied with logic level 0, there will be no channel formation between the source and the drain terminal. That is, there is no connection established between the source and the drain terminals of the MOSFET. Hence, we call that the MOSFET is off. In addition to NMOS transistor, we have one more MOSFET called as PMOS transistor, P-channel MOSFET. In P-channel MOSFET, the P-channel MOSFET turns on when its gate voltage is low and turns off when the gate voltage is high. Or in digital abstraction, when the gate terminal of the PMOS transistor is supplied with logic level 0, there is a connection established between the source and the drain terminals. There will be a channel established between the source and the drain terminal of PMOS transistor, and the PMOS transistor is said to be turned on. When the gate terminal of the PMOS transistor is supplied with logic level high, logic level 1, there is no channel established between the source and the drain terminal of the PMOS transistor, and there is no channel formation. Because of there is no channel formation, there is no connection between source and the drain terminals of the MOSFET, and the PMOS transistor is said to be off. Under digital abstraction, When NMOS transistor gate voltage is supplied with logic level high, NMOS transistor will be on. When NMOS gate is supplied with logic level 0, NMOS will be off. When PMOS is supplied with logic level 0, PMOS transistor is on. When gate of the PMOS is supplied with logic level high, the PMOS transistor is off. The zeros and ones, whatever I have mentioned, is with respect to digital abstraction. But in reality, everything is dependent upon threshold voltage. So we'll discuss about how exactly the MOSFETs operate with the variations of its threshold voltage, how the MOSFETs turns on, how it turns off, what are the different regions of operations of MOSFET. Both NMOS and PMOS will be dealt in our future lecture videos. But as of now, let us just remember the digital abstraction for understanding the circuit operation. When for NMOS transistor, when the gate level logic is 0, the state of the NMOS is off. When for NMOS transistor, when the gate level logic is high, the state of the NMOS is on. Similarly, for PMOS transistor, when the gate level logic is 0, the PMOS transistor is on. When the gate level logic of PMOS transistor is high, the state of the MOSFET is off. So using this basic knowledge, let us try to design, or let us try to understand the operation of an inverter, a NOT gate. So this is how the inverter looks like. In inverter, we'll be using both the kinds of MOSFETs, PMOS as well as NMOS. PMOS forms the pull-up network and NMOS forms pull-down network. The gate of PMOS transistor is connected to the gate of NMOS transistor, which in turn is given as input. The source of PMOS transistor is connected to VDD, which is logic level high under digital abstraction. The drain of PMOS transistor is connected to the drain of NMOS transistor, which in turn is connected to output. The source of NMOS transistor is connected to VSS or ground, whose logic level is 0. The output with respect to the CMOS is always extracted between pull-up network and pull-down network. PMOS transistors forms pull-up network. NMOS transistors form pull-down network. Between the junctions of this pull-up network and pull-down network, we will be extracting the output. The reason why we call the PMOS transistor as pull-up network is this PMOS transistor, because the source is always connected to logic level high, it tries to pull the logic level to up or logic level high. Hence, it is called as pull-up. The reason why we call this NMOS transistor as pull-down network is because the source of NMOS is always connected to logic level 0. It always tries to pull down the logic level of this output to 0. Hence, we call it as pull-down network. We already know that in a NOT gate or CMOS inverter, when the input is 0, the output should be 1. And when input is 1, the output should be 0. How exactly that operates? That we'll try to understand. As already discussed, NMOS transistor turns on when its gate level logic is 1. PMOS transistor turns on when its gate level logic is 0. Initially, let us consider the input voltage or input which we are supplying is logic level 0. So when input is logic level 0, the same input is given to the gate terminal of PMOS as well as gate terminal of NMOS. So because input is 0, PMOS transistor will be on, whereas NMOS transistor is off. So because PMOS transistor is on, there is a definite connection established between the source and the drain terminal, and it acts as a closed switch. Because NMOS transistor is off, there is no connection established between the source and the drain terminal of NMOS transistor. It acts as open switch. So because it acts as open switch, we can consider it as open circuited. So it is not at all present. So if we observe, because there is a closed circuit condition established between the source and the drain terminal of PMOS transistor, the source is connected to logic level high. So this logic level high will be transferred as output, and the output which we get is 1. So this is with respect to the first case. Let us consider the second case, when the input voltage is equal to 1. So when the input voltage is equal to high, because this input voltage is supplied to the gate terminal of PMOS transistor as well as gate terminal of NMOS transistor. PMOS transistor is off because gate input is 0, whereas NMOS transistor is on because its gate input is high. PMOS transistor is off. Because NMOS transistor is on, there is a connection established between the source and the drain terminal of the NMOS transistor. Because PMOS transistor is off, there is no connection established between the source and the drain terminal of PMOS transistor. Hence, it acts as an open switch. Previously, if we remember, the output voltage was equal to 1. Because the output is connected to logic level ground, logic level 0. Because there is a closed circuit condition established with respect to the NMOS transistor, whatever might be the output, because it is connected to ground, the output becomes equal to 0. So this is how a normal CMOS inverter operates. I hope that you have understood this video lecture. Thank you.